Hi everyone, in today's lesson we're going to talk about graphs of hyperbolas. Basically what a hyperbola is that it looks like two mirrored parabolas with the two halves being called branches. So here's another cross section of a cone. See how it creates these two branches? We call this a hyperbola. We could either have a parabola that opens up and down, or we could have a parabola that opens left or right. So we call a horizontal parabola the one that opens left or right. So very similar formulas to that of an ellipse. We have these fractions, but this time we have a minus sign instead of a plus sign. And a couple other things are going to be different. So let's discuss the differences. So A this time is always the first denominator. That's never going to change. And it's the distance from the center to either vertex. And B is always the second denominator. That's never going to change. B is always going to stay there. And B is B units from the center on the conjugate axis. I'll talk about what that means in a minute. And C is the distance from the center to either of the foci. So let me explain through an example. I think that's best. So the first thing that you have to notice here is that we have an ellipse. Why? We have a minus sign and we have a 1. And this time, A is always going to be the first denominator. So 25 and 4, no matter what, bigger number or smaller number, that does not matter. So the square root of the first number is always A. So you could put first number. B is always the second number. So the square root of the second number is going to be B, no matter what. My center, just like a circle here, since there's no parentheses, it's 0, 0. Now we know that this is a horizontal hyperbola. So this first one here, we know it's horizontal. The reason why is because the x squared on top comes first. So that is your indicator. So see how the x squared comes first? That is going to be a horizontal parabola. If the y squared were to come first, then it would be a vertical hyperbola. So the real main difference between an ellipse and a hyperbola is that the tops are now going to switch. The bottoms are always going to stay the same. So the bottom 25 and 4 will never change. So the square root of the first number is always A. The square root of the second number is always B. So let's go ahead and plot the information that we have. We have a center to be 0, 0. And we know a horizontal hyperbola is two branches that open left and right. And the vertices are always the points of the vertex of the so-called parabola. So we know that the vertices always are with respect to A. So we're going to go left 5, right 5, and label these with a V, vertices. We can go ahead and just label those points here. So the vertices here are -5, 0, and 5, 0. So technically our branches are going to be out this way and out this way. But to be more specific and more accurate about how we graph this, we need something that is similar to the covertice in an ellipse. So you see how we had A was the first number, B is the second number. So this B number helps us create what we call the hyperbola box. So let me do it first and then hopefully it'll make sense. So the B value is 2. So we're going to go up 2 and down 2, kind of like those covertices for the ellipse. But now what we're going to do is we're going to draw in a dotted box between these vertices and these blue values that I put here. And this is going to help us draw in our accurate hyperbola. So hyperbolas also have what we call asymptotes. So these branches approach a specific asymptote. So within the hyperbola equation, these branches will approach that asymptote going this way and this asymptote going this way. So the first thing you do before you even graph the hyperbola is draw in those asymptotes. So we can go from corner to corner through the center. So go ahead and connect those values. And if you happen to have enough room on this graph, you can keep going. So how much did we go from the center to here? We went over 2, up 5. So we can go over 2. 5 is a little bit of a stretch, but we can estimate. So over 2, up 5 would be somewhere here. And then on this left side, we can go down 2, and then like 5 is somewhere over here, right? And then we're going to do the same thing for the other side. We're going to put a corner, the center, and the corner. And we're going to connect these. And again, we're going to try to follow the pattern. So up 2, left 5, up 2, this is left 3. We can go maybe a 2 more, and it's close enough. Same thing over here. So now that we have our box and our asymptotes, we can go ahead and put in our branches from the vertex, right? This is our vertex, and the branches go out. And basically, the asymptotes pretty much contain where the branches go. You can't go past them, so just like that. Now, all of these things that we use to help us graph the hyperbola need to have dotted lines because they're not technically part of the graph. Technically, what we should be doing is erasing everything here. Erase the box, erase the asymptotes, but it's really good for us to see where everything came from so you can get partial credit on a test. Okay, and then the last thing that we need to do is we need to find the C value for the foci. This time, the formula is a little different. It's C squared equals A squared plus B squared. So C squared equals A squared is 25 and B squared is 4. So in this case, we have 25 plus 4, which is 29, equals C squared. Now, when we take the square root, we're going to notice that we can't take the square root of 29, and that's okay. We can just leave it in the square root of 29 fashion. But what you're going to want to do is maybe find the decimal equivalent to that. I know the square root of 25 is 5, so it's close to that. So I'm going to say this is 5 point something. We don't know exactly what that is, right? Square root of 36 is 6, so it's in between 5 and 6, so maybe 5.5. So what we can say is we're still going to go from the center, C, to the 5.5, which we'll put here, and 5.5, which we'll put here. So we can call those foci 1 and foci 2. So if we were to name this point, we went 5.5 comma 0 and 5.5 comma 0, one negative, one positive. But just to be more proper and exact with our answer, we're just going to put negative rad 29 comma 0 and rad 29 comma 0. You could put 5.5 if you want, but the choice, this is just as accurate, actually more accurate. Okay, and then the last and final thing is the equation of the asymptotes. So these asymptotes are those yellow lines that I drew there, and we need to recall the formula y minus y1 equals mx minus x1. So my asymptotes, we need to know the point that it goes through. So now the center is the easiest point to use. You absolutely could use these corners of the boxes, but we're going to use this center point here. So in this formula, we have an x1 and a y1, and that x1 and y1 should be your center. So x1, y1, let's use that as our center point. So in this case, we're going to use 0, 0. So 0 and 0. Notice the x and the y in the formula stay the same, right? We're not touching them. Just the x and the y1 becomes the center. Now m is the slope. So slope is rise over run. So how much did I rise? How much did I run? I rose 2, up 2, right 5. So they're both positive. So we can say this is 2/5. So y minus 0 is y. And then we have 2/5. X minus 0 is x. Now with the equation of the asymptote, you're going to notice that it's going to be the same on the other side, just a minus. So plus or minus is sufficient. Why? Because 0, 0 is still going to be that point that we're going to use. But now this time my slope is up to left 1, left 5, which would make negative. We could talk more about that in class tomorrow, but that's the general idea for a horizontal hyperbola. Okay, the last thing that we're going to talk about is a vertical hyperbola. This occurs when the y squared comes first. The a and the b still do not move. A and b are not moving, but this time the y squared comes first. Everything else remains the same. So I'm actually going to get you started on this one, and I really would love for you guys to finish this for homework. So we know this is a vertical hyperbola because the y squared comes first. Center is still the same as if it was a circle. The x comes first, then the y. So the x is a positive 2, so in the equation we make it a negative 2. X comes first. Then the y is negative 4, so the y is 4. A is always the square root of the first number, and B is the square root of the second number. So the square root of the first number is 2, square root of the second number is 3. So this time for a vertical hyperbola, our hyperbola is looking like this, with these two values being my vertices, and my asymptotes are going to be going down this way and this way. So why don't you take a minute, see if you can analyze the equation and the pieces we found so far, graph the center, make the box, try to see if you can graph all this and then state the vertices, foci, and the asymptotes. And we'll start there tomorrow in class. All right, have a good night.